Welcome back. So we are at chapter 5 of IoT security. Now we have already covered the device, the communication. Now we are moving to application. Okay, so that's the highest portion of the attack surface that we are looking at today. Okay, so where are we today? So we'll basically look at the whole entire thing. What are the IoT application at the application level? What are some of the vulnerability? What are the assessment, local application, remote application, messaging protocol, and so on and so forth. And we look at some of the possible mitigation threats, okay, out of this. So next, in terms of the application wise, okay, we always go back to OWASP in terms of application vulnerabilities. Okay, so most of the vulnerability at the application level, well, if you take a look from the web perspective, web page perspective, basically OWASP is web, so username, password, right? Whether the thread is the proper username or not, does it actually identify the username, right? Recently, Singapore has the fiasco of the NRIC issue, right? You still can use the NRIC as a username, but not as a password. That's what we are keep on talking about, emphasizing, right? It cannot be used it as a authentication. Can be used as an identifier, okay? Username, not for password, okay? So the next, immediately after the next thing is a weak password. So NRIC is a weak password. It's not a good password, okay? End of the day, you need to have a stronger, basically the length, either the length is long. In terms of UI design, that's not that good lah. Because if you, let's say, especially IoT environment, if you wear a glove in the winter and very long, how are you going to press the button, right? And sometimes the system may only have a button for you to press, right? So then it becomes become complexity. So you need to add in complexity, right? So it's either a long or complexity, either or, right? So to increase the entropy, basically, end of the day, we have a thing called entropy in terms of password. So to make sure that entropy is big and complicated enough, so the end of the day it's not so easy to do. Additional thing for IoT can be a two-factor authentication. It's not so easily be done because if you have a lot of devices, small devices everywhere, you're not going to do a two-factor authentication. It itself is a machine. It also cannot do a two-factor because if it doesn't involve human being, you're only going to have a password and a MAC address for the as a username, right? So you're not going to have you can only go either have a lot of them, either go on complexity of the password and not having a what I call it a secret rather than second factor. So second factor for certain things yes, for certain things no. Okay, when you machine to machine, no, right? Then it goes when you machine to machine situation, you go into complexity. Okay, when you have human involvement, basically not machine to machine, human to machine, then you can have a second factor to take note of the size and design of the system, how you're going to do it, okay, at the application level. So for the application level, you still need to come back to the physical thing and add on and relook again how you change that to do that. So that is where you can take a look at okay, multi-factor authentication. Okay, next thing is of course I mentioned not everything you can do that two-factor, right? Two-factor means that it's two different type So one can be bio, one can be one-time password, one can be a password also. So there are different channel of communication. Okay, and account locked up. Okay, so the application is been authenticated, but then the account locked up many attempts. So these are the things to be able to limit the connectivity, so the end of the day it will not cause this account locked up issue. Okay, and last but not least, insecure third-party component. Some of the things, especially what we mean by that, this third-party component is not a physical component, it's software libraries, APIs. Okay, so insecurity of third-party components. How to deal with that? Later we'll talk about that more. Okay. The key part is there are a lot of third-party libraries that people are using to develop application. Well, if you talk about web, HTTP, on top of web, you have your Python program that you may, or Java program that you use it to write your web page. Then they all rely on, a lot of them rely on third-party application to sit on top of it to provide the library. So those are some of the third-party component, or even JavaScript. JavaScript is one of the culprit for a lot of breaking a lot of system. That's one of them. What I'm talking about, other kind example, in early days we talk about Flash, Adobe Flash, which proved to be very not secure, right? Java, we talk about a lot of Java API, so a lot of Java API end of the day, which is at the web level, was not secure, so they also bring out of that thing. So Apple was the first one that actually take out the Java portion. Apple also the first one to take out the Flash component, right? Followed by Microsoft. Okay, and Microsoft has their own IE way of coding, which is using either VB or C#. The OCX or whatever extension inside there, it cause a lot of problem to the browser itself. Okay, so that's another kind of third-party component that which is not secure, not very safe, right? So a lot of things come back to, HTML5. Then the next thing is basically JavaScript. So the key part is nowadays the key component, the not so security part, is actually the JavaScript portion, right? So because there's a lot of third-party JavaScript component running around, so try to reduce that down to pure, not overly too many JavaScript, because your end of the day you're going to maintain a programming language that's not very good, that causes the application to have a lot of vulnerability, right? So want to reduce in terms of the JavaScript portion, in terms of the third-party component. So that is one of the main focus in terms of the application vulnerability. There's another few part that we will later talk about, which is software bill of material. Okay, SBOM. Okay, that's one of the key part that we will cover later in terms of the mitigation portion. Okay, this is known as software bill of material. Okay, so local application, let's go and jump even further in detail in terms of the local application. Local exploit. Okay, what in terms of application wise that you're going to have in terms of issue, firmware replacement, right? Update of firmware. Is it properly digitally signed, right? If it's not properly digital signed, then it cause a lot of issues. This has been the past 5 years, a lot of issues is because of that. The very famous case one is the SolarWinds, right? Because of the firmware, is some third party, they managed to intercept and get the signature change, and at the end of the day was not properly signed, and at the end of the day push it down to all the various machines and cause a problem, right? That's a firmware replacement issue number one. Second one is the antivirus company that actually goes into the BIOS level and that firmware was being updated. That is actually not a attack. That is because of the way that antivirus was designed, right, and cause the whole entire system, all the airport, all the machine cannot put up properly in Microsoft, right? So that is not because of that. That is also a issue also end of the day, right? Cause a lot of thousands of machines not working properly, but then that's not a security attack. Okay, but the bigger one that is security attack is the SolarWinds case. Okay, so advanced persistent threat end of the day. Okay, next, cloning, right? Cloning of the machine application end of the day, causing the system not working properly. Denial of services and extraction of security parameters such as username and password. So some of the way, as mentioned, web page, the web developer today, because web is so comprehensive and so widely used, not just on the normal thing, but in a lot of IoT, web should be treated like an operating system. Okay, repeat again, web should be treated like an operating system. So you not only need to have administrator inside a web, okay, development. The developer not only need to think about in terms of cybersecurity wise, not only think in terms of administrator, which most of the packages come with administrator, but they does not comes with a thing called auditor. So auditor account is very important. So the rights at that level to create accounts within the application becomes important. Okay, so you not just have an administrator account, not the way to just to recover the firmware, but you need to have an auditor account or an out-of-band submission of all the logs for your application. So application developer need to think carefully and go further, go a little long further already, because you need to treat the whole entire thing like an operating system. Okay, it is an operating system to remove some of these issues. Okay. Okay. Some of the popular exploit, again, man in the middle, eavesdrop, SQL injection. One of the more related to application wise is SQL injection actually. Let's take a look here. Okay. So SQL, what is SQL? Basically, you have a database, you have a username, password. That's where the SQL injection comes in, right? So let's say you have because of the way SQL has been constructed, so the way to code this thing need to go into, you need to use some framework, right? MVC or whatever, object-oriented programming, a proper object-oriented programming, rather than a direct SQL coding, because SQL cannot deal with once the statement is true, it goes in to your logic, right? So you have 1 equals to 1, you have a logic true here, and that's an SQL injection, right? So these will, if you go directly and give a true and goes into your, you don't even need to check the password, right? You just have a logic true and the system went through. So this is an inherent issue with SQL. Actually, SQL is not broken in any way, but because of how SQL has been designed, this become true, and that if you use a password system that directly use SQL, it becomes an injection error. Okay, so how to deal with that, right? So you need to understand how you do a model view controller, or at least some framework or some design, OO design, right? So you would need to have a controller, object controller pass in before you pass out, and you do proper validation here. Okay, whatever input you do validation. Okay, you convert into an object, and then you validate it properly before you have a separation. You have a proper middleware end of the day, right? So that will actually successfully break out from SQL injection. Okay, next thing is route. Okay, can place a root router for routing in the network itself. Okay, so that's one way of talking about the route issue of application. So those are local attack for application itself. Okay, so those are the local exploits. Okay, next we move on to the next part. Then you have mobile application, right? In terms of the application wise, the communication. Let's say you have a mobile device, so you have an insecure communication. The connectivity that you have, whether the data storage is properly done, right? Nowadays this is less and less, because both if you are either in the Apple or Android platform, this should not be an issue, because everything is being encrypted properly. Okay, nowadays communication is getting better and better because of the fast changing of the phone. So all the communication have been upgraded to a newer protocol. You no longer run 2G anymore. Many countries, right? Slowly we're cutting out all the 2G and we're all shifting to 3G. So the communication is getting better and more security. Of course, it's even better to go to 4G and 5G in terms of security wise. Okay. Do note all these notes was earlier on in 2016. So those days still have 2G and some of the insecure protocol. So as time goes by, it get better and better. Authentication, it got better, right? In terms of the mobile platform, right? multi-factor, you have fingerprint, you have all kind of stuff nowadays with your phone, right? So it's become a better platform. And then last but not least is the improper usage of the platform, right? In terms of the application, whether the device has been installed some improper application, third-party side channel installation, then it causes some issues. So do be careful about side channel install application that is not official. So most of the time the platform will double check the thing lah. So I would say 80% of the platform application, which is whether you talk about Apple Store or Google Store, are pretty safe. What is left is that 20% that may have left the whatever system, but then every now and then there are people who check the application, and because it's a paid service, it doesn't last very long if the thing is trying to, unless they are making money out of the whatever it is inside there. Okay, so that is the key part of local application for mobile application. Okay. Next, web and cloud application vulnerability, because eventually mobile part is just one of the component, right, for the UI portion. The other part is the SQL, again, come back to SQL injection, right, SQL injection, but then it also can be a LDAP injection, right, the log4j case, okay, that happened earlier on, recently, right, log4j case. Okay, so that is the one of the vulnerability to look into, right? And then some of the XML external entities, right, that may people are using it to disclose files and file sharing for port scanning. So people are trying to avoid XML lah, end of the day, right? Just I mentioned just now, like some of the thing. Then you may shift to JSON lah. JSON has got better because more and more people are using JavaScript JSON, and that security actually overall JSON it got better and better, right? Because of the way we design, the improvement of the API, and so on and so forth. Then the next thing is API exposure, right? The security wise, if your JSON are done properly and you do a proper JSON communication with the proper API, then this thing will be less. Okay, but I'm not saying that there's no 100% things, but then do think in terms of web. Over here, a lot of time we talk about web application firewall. Okay, and of course, update of firewall. This is firewall. So your WAF plus together with not just at the application level firewall, but additional thing such as TLS 1.3. Okay, so do take note about these two different new technology that need to be done at the network level to protect the application itself. Okay, the thing is radically different from TLS 1.2 and without web application firewall. More and more cloud service is Google, Microsoft, Amazon are all putting it their own, provide end user with a web application firewall. It's just a matter of whether programmers, developer, and whoever know how to use the firewall or not, and enable the firewall. That's number one, right? Then also, how do you redesign your system to make use of TLS 1.3? So it's a true end-to-end encryption. And thereafter, you do make use of your VPN for the whatever leftover side-to-side VPN for your encryption, right? So you can actually do proper filtering using your web application firewall, which may include all your antivirus scanning within itself, right? So that's one of the things. But all these things are in the consideration that you have a proper access control and you have a proper authentication process and everything that you have actually properly configured correctly. So as much as possible, make the whole entire thing software defined again. We will still come back that I mentioned many times. It needs to be software defined. So that the API that you choose need to be able to support that. The hardware need to be able to support that. End of the day, reduce human involvement and allow software to do the automation and allow to collect security profile, create security profile from all entities within the application itself, and that will lower security risk at the end of the day. Okay, because it's not humanly possible lah. You day in day out every system, so you're moving from a static system to a smart system that can automatically detect and do all the necessary stuff. Most vendors support only static system, Excel. Basically, that's it, right? So asset management and all these things kick in, and automation kick in for all that thing and make that thing become a security perspective with security profile, smart security profile, and start the software-defined component, so that at the end of the day, the system will run it properly. End of the day. Okay. So device management, right? Next thing is device management. The data can be stored in the edge, okay, or at somewhere in the cloud, end of the day, right? So edge is one kind of processing. How efficient are we talking about content? How much of this you can do it as a content distribution network, end of the day? So it comes back to a point that all these things through Unity immediately, okay? So you need to have a bird's eye view of the whole entire system and understanding in terms of computation system, where the data should lie. Are you using proper queue system? Later we'll talk about MQTT, some of the queue system, right? Okay, make use of the queue. How are you going to properly distribute the data? And then how do you properly encrypt the data? When you do your communication, do you add in your data at rest? Then data in transit, okay, into perspective. I'm not asking for the data in use. Not all situations you have data in use, but at least data at rest, encryption, data in transit, all the protocol will have proper encryption and authentication. It's an authenticated encryption, okay? That is why we are moving to TLS 1.3, right? So most of the encryption need to be at least authenticated, right? You have encryption itself is not good enough. You need to know who you are communication with, right? And what kind and then what are the kind of protocol that can be efficient for IoT yet provide the security. There are a lot of hardware nowadays support all the things which I mentioned earlier on, okay, like ESP32, and they come to all these kind of chipsets, right? Engineers need to figure out how to do all these necessary programming end of the day, so that you can actually provide a better secure system end of the day. You must always think about not everything must be in band. It can be an out of band system, okay? Certain things can be in band, certain things can be out of band. And end of the day, to provide the efficiency based on the kind of CPU, the kind of storage, the kind of power, basically your battery lifespan, and create what we call in all what we call a dependability system, reliable and secure end of the day. Okay, so that's what a dependable system is. Okay, so some of the guidelines for secure web application is review some of the vulnerability, weak password, brute force attack, two-factor authentication, some of the encryption, right? As I mentioned just now, test for all the various vulnerabilities, set password to expire. This is not the exhaustive list. The exhaustive list is still come back to CIS benchmark, okay? Or if it's a military, that you go into the military one. Okay, so hardening is important at the end of the day. That's what we are talking about. So password, right? So we go a little bit further down on the password part. Password part, the biggest problem is conventional password is a user, right? Just some username and password, right? As I mentioned, the IC portion, right? This is identifier. This is for authentication, right? It has some criteria. It need to be easily remember. Because if you user cannot remember, they tend to not to use those kind of password. Okay, but it needs to be difficult to crack end of the day. So complexity will need to come in. Okay, password complexity need to come in. Okay, people need to understand some of these feature in terms of complexity wise. Okay, so such as not just A to Z, comes with cap or no cap, comes with numbers, comes with special characters. Okay, so password can be need to understand how all those things comes into. I believe you understand that portion because we went through the lab on the password hacking portion. Okay, so many you should never use default password, right? Because it's like telling the whole world what is the password is. Okay, so must always change password. At least change once. Change once is still better than don't change. Okay, and all these are the result of how threat actor, bad guys actually make use of this thing to take over the system. Next. Okay, web front end vulnerability, cross-site stripping. We just now mentioned. Some of the web front end, if you have a web page, then you may use a JavaScript way of putting additional script in, and so wherever you need to key in the thing, as I mentioned, you need to have you put in a middle portion, and you always do object checking. Okay, object verification. Okay, object verification, so that end of the day it will reduce whatever cost right attack you have. Of course, that will at the same time reduce your SQL injection. Okay, last but not least, authentication, broker authentication. The key part that most vendors actually are weak in this thing is not just the authentication itself. If you talk about modern protocol, you talk about CHAP, whatever, right? CHAP is the most common protocol that most people are using, CHAP, Challenge and Handshake Protocol, right? The biggest problem with CHAP is your hashing algorithm, right? Since about 5 years ago, we should already given out MD5, no longer MD5, no longer SHA-1, right? These two has been broken. Minimum hash for whatever chat you should have is at least a SHA-256. That's minimum, right? Because all these things is not reliable anymore. So that's where the authentication portion need to be done, strengthened. Number one. Number two is, of course, session token left hanging in the air. That is basically bad programming for the web. Okay, it come back to the object-oriented verification and proper object-oriented programming at the web level. Okay, it just basically just tell you the programmer is terrible. The programmer doesn't know what they're talking about, right? You need to find a proper programmer, a programming skill set need to go up in order to do a proper object-oriented programming with framework with ORM. Okay, object relation model. ORM is a must. Your MVC, whatever framework is a must. Okay, with all these and with secure programming methodology, the code should be 10 times better than whatever existing code is end of the day for web. Okay, these are not something new. This thing has been around for industry for ages. Okay, so at the application level, how do you look into as a threat model end of the day? So need to decompose your whatever application you need architect. You need to decompose the application into several parts. You need to use a strike, right? Look at the model, identify the rating using strike, okay, to break down a thing, look at whether everything can be smooth, can be changed or whatever, right? And last but not least, to recommend the mitigation method end of the day. So if you look at various protocol, then after that we go now the key part is that is just a threat modeling, but then the more important thing is look at all the various protocol, right? HTTP is one of the very common protocol used in IoT web page, obviously, right? It's not a very efficient messaging protocol, a lot of time, but today for update of patches is still highly, a lot of people are still using HTTP patched. Okay, there are better way of doing patch rather than using HTTP, but most of the protocol today are still using HTTP as the mechanism for patching, which is bad. Okay, because there are no verification, it is an end-to-end patching. There is no in the middle to do proper access control. HTTP does not allow a proper access control. So everything goes. If you have a mechanism that does proper access control, fine-tune access control would be a better way than HTTP for patching. Unfortunately, this is not true today yet. Okay, still. So that is one of the pure weakness of HTTP. Okay, there are some other messaging protocol, right, such as MQTT, okay, CoAP, and SMAPP. Constraint application is not very advisable because it still come back to very similar to HTTP. It's just meant for a low powered system. Why would you want to go for a low powered system, an 8-bit system? Why still stick with a 8-bit processing? Because of programmability, people are going for low code and no code anymore. So this thing, even though it's invented by IETF, it is not an advisable thing. A better protocol is MQTT. Okay, a better protocol is MQTT because it is a proper pass-up, publish and subscribe model that allows fine-tune, which whatever I mentioned just now for SS, ACL, eventually. So this is actually one of the more critical portion to choose versus CoAP, which is the constraint protocol. Okay, XML protocol, extensible protocol was designed for instant messaging originally. Those days, because of everything want to change into XML, but web kind of data and all this kind of stuff. But then, is it good enough or not? All right. XML is good because of the way of documentation and all these things. All these things go back to, of course, HTML, then HTML, then borrow whatever and move into XML. The issue with all this way of coding, it is text-based, everything is in context. The problem is efficiency. You have too many text, right? People hope that it can help in terms of maintainability. Actually not really true anymore, right? If you're just talking about web page, fine. But then if you want to talk in terms of it has too many words for identification and processing. It may not be such a good XML may not be such a good design end of the day, for whatever purposes it is. But there's a big but. Because in ITF, you have the yin and yang protocol. Your yin, which is XML, and your yang, which is JSON. Okay? So there are still quite a bit of PC system for modern, we are talking about power system of your CPU or whatever, is based on XML. So you can't 100% avoid XML end of the day, right? This is just talking about XMPP. There are a lot more things going around with XML for in terms of even for software defined stuff that is basically XML basis. Okay, so those are for power management system. Okay, so those are essential. There are still a lot of replacement on top of that at that level. But then, fortunately, ITF recognized that they are pushing out a lot of things that are based on JSON and YANG. Okay, so it's a good thing if whenever possible try to push towards the YANG model design rather than the yin design end of the day. Okay. So that's one of the characteristics of some of this messaging protocol. Okay, so the key part I will want to cover mainly for this chapter is MQTT, because in Singapore most of the public agencies are using password, basically MQTT. Okay, MQTT is developed by IBM for machine-to-machine communication. Okay, it is using a publish and subscribe model, right? So you have a broker. The good thing is that it's separate between here and here. So the whatever the publisher sends has no impact on what the subscriber is alive or not alive. That's one of the key feature that MQTT provides. Most of the people forgot about the security portion. The key feature in security, the very, very good security feature, comes in because of the ability to do proper ACL here. Access control. Okay. With the additional of the broker, it not only allows the breaking of the two portion into separate silos and loosely coupled connectivity, which is good for software design and not hardly coupled, right? Because when you have an end-to-end device, once goes down, everything goes down, right? So because of loosely coupled, it increase reliability, redundancy, and allow access control to happen. So that's very important for cybersecurity in IoT at the application level. So a lot of things can be sent over to the cloud on whatever sensor that you have. Okay. So CoAP is a lightweight protocol. It's an end-to-end system, even though it has a so-called web server, but you see, CoAP is a direct connections. Okay, and then it has some database. So once one of the system is down, it's down. You need to think, if it's MQTT, I'll put a broker in between here and here. So there's a, if it's MQTT, then I'll put device here. So there's a broker. Okay, so why people like that? Because of the CIUD possibility. In actual fact, MQTT also can do the same CIUD as well. There's no advantage that CoAP in the overall architecture, right? The next thing is, okay, if you talk about low-end device, they're okay when talking about, okay, constrained device, we'll talk about battery life. Please make sure that, because 8-bit does not mean you can string your silicon further. It's the size of the silicon that matters. You can go with 32-bit, even 64-bit processor. Today, the design. So it makes no sense to go on to 8-bit that end of the day you have a hard time in terms of your all various communication, because end of the day, if you think carefully, right, when we talk about internet, what do we mean? What do we mean? Right? When we talk about internet, what does it mean? It means minimum you need to support internet protocol. Version 4, IPv4, right? What is IPv4? Fundamentally, if you come back to the root cause of this thing is a 32-bit protocol, because the address is 32-bit. So why do you care about 8-bit? Throw out all the legacy system and don't use those kind of stuff. Upgrade those to a 32-bit processor, end of the day. And once you jump into this era, you no longer need CoAP anymore. That's the thinking. That should be the right way of doing. It's just because they want to save costs and whatever. It doesn't help at all, because running too many 8-bit system is not helpful for power efficiency, not green for the environment, worse, not secured, and not going to give you whatever reliability that you're going to have. So if you have an existing system, don't connect them to the internet. If you want all these things to connect to the internet, upgrade everything to 32-bit processing, minimum. Right? So that is the proper way to do design of systems. If the thing is, end of the day, okay, that thing has been around for 30, 40 years, don't ever connect that thing to the internet. If you want to connect that thing to the internet, have a system, a controller that supports 32-bit processing. And that point connects to the rest of the internet. And here, you probably want to upgrade as much as possible for all these devices eventually to all 32-bit end of the day. Because security and reliability and dependability end of the day is the important thing. Cost is not an issue anymore for 32-bit system. For the past decade, the cost has come down tremendously. Okay, it's just a matter of whether the engineer figure out how to do it or not. It's real cheap, right? If you talk about even 8266 is like what? Few cents, right? So those are the consideration. Don't ever go back to 8-bit anymore, right? It does not make any sense. It doesn't help anymore. It's legacy, right? Other protocol, right, such as XMPP, so on and so forth, doesn't help a lot of system. Of course, there's DDS, which is direct connections, right, for digital imaging, automotive testing, air traffic, and complicated for high use of IoT system. Okay, so do know some of these protocol. They are running around. Sometimes do make sure that they are properly securely designed, such as MQTT. MQTT actually slowly getting into the point that helps in terms of that. Try as much as possible to go into a pub-sub model, publish and subscribe, so become loosely coupled, so that the trusting zone can be properly designed and you can have access control list eventually. Okay, that helps not only in terms of over security, it also helps in terms of patching. Patching is part of cybersecurity. Okay. Okay. Then there are some other IoT protocols such as universal plug and play. Those days now is hardly used anywhere. It's not a very there's a lot of flaw in the design itself. So people have moved out of this system. So shall not go into much detail on this thing. If you have used this thing, try not to connect them into the internet and don't use them anymore, because all these things has been retired and move on. And that's it. Okay. Thank you very much. And I'll see you next time. Bye bye.